Mars has always intrigued scientists with its mysterious atmosphere and the possibility of hidden secrets. Despite decades of research, the planet still holds many mysteries, which are gradually being unveiled each year. In recent years, discoveries have been happening one after another, each capable of drastically changing our understanding of the neighboring world. Every new result from missions, whether rovers or orbital stations, adds a new brushstroke to the overall picture. But it is often the unexpected findings that become the key to solving the deepest questions. And now, one discovery has truly stunned scientists. This event not only raised complex hypotheses, but also sparked a rapid reassessment of established theories. Want to know how this discovery could impact the understanding of Mars's geochemistry and its past? Subscribe to our channel to stay updated with the latest news and most exciting research. Don't forget to like if you're intrigued by the mysteries hidden by the red planet. On May 30th, the Curiosity rover accidentally ran over a rock and cracked it open, revealing yellow crystals inside. Analysis using an instrument mounted on the rover's arm showed that these crystals were made of elemental sulfur, a surprising discovery, as only sulfur-containing minerals formed by water evaporation had been found on Mars before. The presence of pure sulfur raises new questions for researchers. NASA noted that until now, elemental sulfur had not been encountered on Mars, and it is unclear how it might be related to other sulfur compounds found in the area, if such a connection even exists. This discovery is particularly significant due to the unusual conditions required for the formation of pure sulfur. Its formation is usually associated with a very specific environment, which experts believe is not typical of the region where the rover is operating. Furthermore, Curiosity found not just one rock, but an entire field of bright yellow stones with a similar composition. One of them, nicknamed Snow Lake, was photographed on June 8, 2024, 9 days after the first cracked sample. The rover is working in the Geddes Vallis Channel, a deep valley on the slopes of Mount Sharp. This channel was noted by scientists even before Curiosity reached it. Researchers believe it was formed by powerful water flows and avalanches that carried debris now stretching over 3 kilometers along the mountain slope. Since the beginning of 2024, when Curiosity arrived at Geddes Vallis, scientists have been actively studying the origin of the rock formations in this channel. New data suggests that both water flows and dry landslides played a role in the formation of debris piles. Some of these piles consist of rounded stones typical of river environments, while others are made of angular fragments, characteristic of dry avalanches. One image taken by the rover on March 31st shows how water and debris flows may have formed large piles of rocks. Faint white halos on some rocks indicate chemical reactions caused by underground water that infiltrated through cracks in the rocks. These halos were exposed by wind and sand erosion. Researchers admit that the activity in this part of Mars has been far more intense than they expected. This is confirmed by the complex structure of the channels, evidence of numerous floods, and the movement of boulders. Becky Williams, a scientist at the Planetary Science Institute in Tucson and deputy principal investigator of the Mastcam camera aboard Curiosity, emphasizes that the geological structures found indicate significant past activity. To better understand the geological history of the channel, the mission team aimed to collect a rock sample. Although small sulfur-laden stones proved too fragile for drilling, a large rock nearby named Mammoth Lakes was discovered. After carefully selecting a drilling site, Curiosity successfully drilled its 41st hole on June 18th and extracted a rock sample, which was sent to the rover's internal scientific instruments for analysis. After drilling and analyzing the Mammoth Lakes, Curiosity continued its investigation of Geddes Vallis, aiming to uncover even more secrets of this ancient and complex Martian landscape. What unexpected scientific results might be discovered during Curiosity's mission, which has now been ongoing for over a decade? What studies will help scientists in the future find evidence of life on Mars? And how might this affect our understanding of life beyond Earth? Curiosity is an American robotic rover sent to Mars to study its surface. It was launched on November 26, 2011, from Cape Canaveral in Florida, aboard an Atlas V rocket, and landed on August 6, 2012, in Gale Crater. The rover is about 3 meters long and weighs approximately 900 kilograms, making it the largest and heaviest of all the rovers on Mars. Unlike previous missions, Curiosity did not use cushioning airbags during landing. Instead, due to its large size, it was lowered to the surface by a sky crane consisting of 3 cables. The landing process was extremely complex. After the parachute slowed the descent, the spacecraft dropped a heat shield that protected the rover during atmospheric entry. Then, rockets, stabilizing the vehicle, allowed it to hover in the air, shielding it from winds. The mobility system, including wheels and suspension, was already prepared while the rover was still airborne, allowing it to begin its mission immediately. The landing involved 15 critical steps, and the entire process lasted about 7 minutes, which became known as the 7 minutes of terror, as any mistake could lead to mission failure. Curiosity is powered by a thermoelectric generator, which converts the heat produced by plutonium decay into electricity, allowing the rover to operate even in the Martian winter. Among its scientific discoveries is confirmation that Mars may have supported life in the past. It found traces of organic molecules in rock layers dating back 3.5 billion years and detected changes in methane levels in the Martian atmosphere depending on the season. By 2020, the rover had traveled 21.8 kilometers within Gale Crater. The rover also conducts various experiments, including using a neutron beam generator to detect water ice up to 2 meters deep. Additionally, it uses a mass spectrometer, gas chromatograph, and laser spectrometer to study carbon-containing compounds on Mars. Furthermore, Curiosity is equipped with cameras, one of which records high-resolution video at 10 frames per second. The discovery of sulfur on Mars, combined with the detection of organic molecules and traces of water, helps scientists create a more complete and layered picture of the planet's geochemical and climatic evolution. These data could be a crucial step towards understanding how Mars's atmosphere and climate have changed, and also open new horizons for the search for signs of past life. We are on the brink of exciting discoveries that could change everything we know about Mars. Subscribe to the channel to keep up with the latest news and not miss important updates in the field of space exploration.